Hi, and welcome to question 8 of the 2024 paper 1 for the Leaving Cert Ordinary Level Maths. So question 8 here, we'll get started. A part 1, it says Liam left home at 7 a.m. He cycled at a constant speed for 20 kilometers until he reached the point A. He then changed speed and cycled at a constant speed for a further 12k until he reached the point B. So we see on the graph, we have on the y-axis the distance from home. On the x-axis, we have time, and then he's traveling at a certain speed, and we're told that is 20 kilometers. So you see there up as far as here, and then a further 12k up as far as there. So that's, now I don't necessarily need all these in the graph, just making sense of it. It says use the graph to estimate the distance Liam had cycled by 8 a.m. So 8 a.m. is where we're focused on over here. And let's clear off the fluff here. So at 8 a.m., okay, we hit this point. Now that comes across, and I'm going to estimate like 13 kilometers. Now in the notes, I must have made a mistake here because I said 11. It's obviously not 11, like that's 12, 13, 14, 15, 16. So 13 seems like a decent guesstimate. Now part 2 here says find his speed in kilometers per hour when he was traveling from A to B. So I put in this part of the graph. Now there's two different strategies here. We could use like the slope, because slope is in this context the change in distance divided by change in time. Okay, now the slope here will be the same thing as rise over run. Now in this case the rise is 12 kilometers over a run of half an hour. So that would be 12 over a half, which would be 24 kilometers per hour, which cycling would be not unreasonable. Now, if that was running or something, you'd have to second guess yourself, but cycling wouldn't be unreasonable. Now, another strategy we could use there is the speed is equal to distance over time triangle. Now, again, the distance there is 12. The time, because it's kilometers per hour, we're told that this is 30 minutes, which is half an hour. Again, 12 divided by half is 24 kilometers per hour. So that's that. Same thing I've done there in the notes. Okay. So part 3 says use the following information to complete the graph on the diagram above. Now, I screen grabbed it in to show the rest of Liam's journey. Now it says then Liam stopped at B for 30 minutes. So if you're stopped, your distance is not changing. So for 30 minutes, okay, he was here to here. Then he cycled the 32 kilometers back home at a constant speed, and it took him an hour. So from 9:30 till 10:30, that was his distance. Now that should be straight. I'm not using a ruler, so my bad. So look at the answer in the notes. That's the first criteria. And then the second one is his constant speed journey. So from 0 to A, he was traveling at a constant speed. Then he sped up, then he stopped. He now it didn't slow down, but he went back to point 0. And that's it. That's part 3. Okay. So part B, part 1 says Ellie takes up running. In the first week, she runs 6 kilometers. Each week after this, she runs 1.5 kilometers more than the previous week. Then it says complete the table below to show the distance Ellie runs each week for the first 6 weeks. So the first week was 6 kilometers, then 1.5 extra, 7.5. So 1.5 extra then would be 9. Then 10.5, what's that, 12. And then 13.5. I should use a calculator to make sure I'm doing it right because it's very, very easy to make a mistake. Now it says if Ellie continued with this pattern, find the distance she would run in week 100. So we could use like you just keep going for 100. Like in essence, trial and error, but that could be very onerous. Or we could use the total number of an arithmetic sequence, which you find in the math tables, which is a plus n minus 1 times d. Now, t of n is what we're looking for. Okay. A is the first term, which is 6. N is the 100, because we're told week 100. And d is the difference of 1.5. So if we fill in all those parts, t of n is equal to 6 plus 100 minus 1 times 1.5. Now in the notes I have that done out. So that's the calculation here. And when I put it through my calculator, I got 154.5 kilometers, which seems fine. I'll just keep going for part 3. It says, explain why Ellie cannot continue this pattern indefinitely. Okay. Well, like, I suppose the answer's there, but if she ran for 300 days, she would be having to run like on the 301st day, like she'd have to run 400 kilometers in a day, which just wouldn't be physically possible. Okay. So I'm saying there, if Ellie ran for a few years, she would have to run over 300 kilometers per week. This would not be possible. That would be way over. Like, think about it, every week. Like after 100, that weeks. It's each week she's going. So in 100 weeks, which is like what, 2 years, a little less than 2 years, she's running 154 kilometers. So in 4 years, she'll be running 308 or whatever kilometers, which just wouldn't be feasible. Okay, so it's not. That's what the indefinite thing. It can't happen indefinitely. I'm just going to say that in whatever way you say it. Now, S of n, this formula is given to us, so let's just look it up. Now we're looking for S of n. Okay, so that's one of our unknowns. And then they're saying after n weeks. Okay, so we can't actually solve this because there's 2 unknowns. A is still 6 and D is still 1.5. So we just continue as if we're doing it normally. Okay, that's supposed to be an n. 2 times 6 plus n minus 1 times 1.5. Now if we just keep going with that, n over 2 times 12. Now 1.5 times n is 1.5n. 1.5 times minus 1 is minus 1.5. These two terms can combine together. Now that's what, 10 and a half. 10.5 plus 1.5n. Now if I do the maths of that and multiply it in, I'm going to end up with S of n is equal to 10.5n over 2 plus 1.5n squared over 2. That should be fine. Okay, so we got on the answer. Okay, the answer I just went a step further and just divided the 2 in. So 2 into 1.5 goes 0.75 times. 2 into 10.5 goes 5.25. I'm not 100% sure if this would be, I'm fairly sure that would be acceptable. Yeah, fairly sure that'd be acceptable. Okay, so 5 says, using your answer to part B4, or otherwise find the total distance run by Ellie in kilometers after 10 weeks if she continues the pattern. So find S of 10. Okay. Now we know now that n is equal to 10, a is equal to 6, d is still equal to 1.5. So we could just start from fresh, or we could just use that model there. S of n is equal to 0.5. Now, memory of a sieve. Actually, let's go to the answer. There's the model from part 4. We know now that n is 10, so substitute 10 for n in both places. Put it through the calculator, and I got 697.5 kilometers. Okay. Which wouldn't, that's not unreasonable. Like, that's 10 weeks of running, so it wouldn't be that crazy of a distance. Right, so that's the end of question 8. So as always, if you want a copy of the notes I'm working on, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 9.